Last time I talked about the preliminary stuff when it came to logarithms. Let's review a little bit what we talked about, right? What we said was when you have a logarithm, the answer to a logarithm is always the exponent, okay? So if I have, for example, log base 3 of, let's say, 15, what I'm looking for is, what is the exponent of 3 that would give you a 15, right? And it could either be a whole number, a fraction, a decimal, and so on. So that's what we're looking at. And then we learned some properties. One of the properties we learned here is if you have log base 2 of 2, what you're asking is, what should the exponent of 2 equal to in order for you to get a 2?
1.
It's 1, right? So that, it should just be like second nature, that you just sort of know, okay? So now we're going to use that property in order to evaluate some logarithms. All right, so when you hear or read the word evaluate, it's get a numerical answer. All right, so we're going to evaluate each logarithm. The best thing to do, or what the process is we're going to take this number and we're going to write it in terms of this base. Okay? So we're going to take this number and we're going to write in terms of 2. Why 2? Because the base of this logarithm is 2. All right, so that means this is going to be log base 2. And what's 16? All right.
4.
Right? Exactly. So now, here is another way you could do it, the easiest way. Okay? What is this asking us? Right here. What is this asking us? Right. What should the exponent of 2 equal to in order for us to get 16? So what do you think? 4.
Duh.
Right? And if you do it that way, it's by far the easiest way to do it. Okay? You don't even have to rewrite anything that way. So what about this one? This is the base. And every base needs an exponent. So the exponent of that should be a 2 in order for us to get 25.
Wow.
Now, this one, you have a root. So log base 3. Remember what we said before? How can I write a root? 3 to the power of?
1/3.
1/2. Right? So take a look here. So now, look at this one. What should I have as an exponent of 3 to get 3 to the half? It's 1/2. Okay? Right? So look, so if you have log BB, you could, they just go away, and it's just a half. All right, so take a look at this one. What should I have as an exponent of 8 in order to get 512?
3.
No, 4.
Wait, 3, 4, 5.
So how would you do it? Let's say, right, 64. 8 times 8 is 64 times 8, right? So if we had 64 times 8, you get 512, right? So could we do that mentally? 64 times 8? 64 is 60 and 4, right? What's 60 times 8?
8 and 4, 2 and 4.
480. What's 4 times 8? 32. Together? 512, right? So the answer to this will be 3. You will be, but I would like for you to be able to do some of the stuff mentally, right? This is why we're in this class. We're gonna, this is the point, like this is the point of this class. Now, all right, so this one, all right, this is one of our properties. So if you go here, this is one of our properties. B to the power of log bx is just x. So if I have 22 to the power of log 22, those all go away and I'm left with 15.5. And that's it. Okay?
What if it's not like 22 and long, like 34 or something?
Then you won't be able to do it.
Oh, so it always has to be like.
So the thing is, this number and this number have to be the same, right? Like the 22 and the 22, they have to match up. Okay, now take a look at this next one. The question is, 3 to the power of what will give me 1 over 3? Not -1, okay? So here's how I do it. Here's how I do it. I have a 3 here, I have a 3 here. So just forget about the fraction. 3 to the power of what gives you 3? Well, it's a 1. And anytime you're going back and forth between a whole number and a fraction, the exponent is going to be negative. All right? So that's how we would do it. So for this one, for example, forget about the fractions. All I do is look at the 5 and the 125. 5 to the power of what is 125? Right, 5 to the power of 3 is 125. But since we're going from a whole number to a fraction, it's going to be -3.
Yahoo!
Okay? Now, later. Okay, so what we're going to do is this. We're going to talk about common logarithms now. So we talked about logarithms, and you saw that a logarithm can have any number as a base, right? The most common base for a logarithm is base 10, right? So those are called common logarithms. Those are just logarithms with a base of 10. Now, it's so common, in fact, that if a logarithm has a base of 10, we don't even write the 10, we just omit it. It's just like we never write 1x, or we never write x to the 1, right? If the exponent is a 1 or the coefficient is a 1, you omit it. So it's the same situation. So instead of writing log base 10x, we simply write log x, okay? So if you see log x, log 3, it's not a typo. Nobody forgot to put in a base. It's a base of 10, okay? So you just know. All right, let's review powers of 10. All right, what's 10 to the 1? 10. 10 squared?
100.
100. 10 cubed?
1,000.
And then 10,000. So what do you notice? Whatever the exponent is, that's how many zeros there are. So now, 10 squared we said is 100. Actually, that should be 10 to the 0. Sorry. What's 10 to the 0? 1. And what's 10 to the minus 1?
1 over 10.
It's 1 over 10, which is 0.1, right? And I don't know what happened with my counting here. Let's go in order. 10 to the 2 and 10 to the 3. Negative 2 and negative 3. So 1 over 100, which is 0.01. The exponent are just going from 0, -1, -2, -3. And then it's 1 over 1,000, 0.001. So, again, whatever the exponent is, that's how many zeros there are, and that's how many decimal places there are. All right? So, same properties of logarithms. Take a look at this one. You have log of 1, right? What's the base here? 10. So the question you're asking is 10 to the power of what gives you 1? 0. Okay? So then if you have log of 10, what's the base?
1.
The base is 10. So 10 to the power of 1 is 10, so that'll give you a 1. Right? So it's the same thing over and over and over and over and over again. All right. So these log of 10,000. Okay? So what's the base here? 10. That means what should the exponent be in order for me to get 10,000?
10 to the 4, 4, 4, 4.
4, okay? What about this next one? It's just 12.
Oh, because the water's already done.
Right? It's 10 log 10 and it goes away. What about the next one? Well, you can't do it by hand. Okay, we'll come back to it. What's log of negative 12? No solution. Okay, so, okay, log 14. Let's go on our calculator. So, hit log 14. Okay, with logarithms, we always go to 3 decimal places. So it's going to be 1.146. 1.146. Always 3 decimal places. All right. So your quiz will have 2 parts. Some that you must use a calculator, like C. Some that you should be able to do without a calculator, like all the ones you just did on that handout. Okay? Okay, now, this is the common logarithm, not to be confused with the natural logarithm. All right. So, yes, the logarithm likes a base of 10, but its soulmate is base E. All right? Remember E, the one that Euler created, and not created, but he came up with, right? He found, he discovered. It's that E. How much is the value of E? 2.718. So a natural logarithm is a logarithm with a base E. So for example, if you have log base E of 4, log base E of 2.1, and so on and so forth. But it's like they're soulmates. It's the natural base. It has a special name, ln, called for natural logarithm. In French, it's reverse, right? It's logarithm naturel. That's why it's ln, right? That's where it comes from. So in other words, we never write log base E of 2. We just say ln of 2. So if you're walking down the street and you see log base E of 3, that's just silly. You just write it as ln of 3. Okay?
What about ln E or ln E?
Okay, so now, here we go. What if you have ln of 1? What is that really? ln of 1? That's really log base E of 1. So now ask yourself, what should be the exponent of E in order for you to get a 1? 0. So this is 0. Now, what if you have ln of E? That's like saying log base E of E. What should the exponent of E equal to in order for you to get an E? 1. So ln of E is 1. Right? ln of E is like log base E of E. For what should be the exponent of E in order for you to get E back? 1. So ln of E is one of those things where if I call you up at 3 a.m. and I say, what's ln of E? What should you tell me? 1. Okay, so ln of e to the x, just x. Okay? E to the ln of x, just x. Okay? Now, so then what would be the answer for part A here?
4.5.
4.5.
Look at that.
What about, no solution.
Maybe we should call Gab.
4.
What?
What else? ln of 7. Calculator
Wait,
time.
why is that 4?
Wouldn't it be like, or like something 1.946.
So ln is second, I'm sorry, not second, it's the E button. ln of 7, 1.946. Or that. Huh? You can. It's always cooler. See, when I see things like that and I'm grading a test, I'll be like, who is this person? And I'll flip back, like I'll flip forward, right? Okay.
Oh, E is 2. E is 2.
Wait. E is 2. Well, okay, he says E is 2. So
No, E is 2. The answer is 2. The answer is 2.
he says part E is 2. So let's see.
Like E.
Okay. E to the ln of 4, how much is that? 4 minus 2, 2.
Yeah.
Because ln of E is 1. Okay, don't ruin the next one. I want everybody to have a chance to do the next one. Have at it, guys. Okay.
Wait, don't do it yet.
So this part gives us a 3. From here you have a 4 times a 5, so that's 23. All right? Because it's 4 times e to the ln of 5. So 4 times 5. So it's okay, so it's 4 times e to the ln of 5, which is 4 times 5. Okay, this next one, similar to what you were doing before, but not really. Okay? Okay, so take a look at this next one. This is reverse, right? So how are we going to do this one? You have log 25, right? And then what do you have here? 5 to the power of 1/3. Okay? So, what do you think here? How is this going to work?
It's just 1/3.
But it would be 1/3 if the 5 and the 25 were the same. But they're not. So, here's the question. Can I write 5 in terms of 25? So what's 5? It's 25 to the power of what gives you 5? 1/2. Okay. So here's the question. Times 1/3. So now the answer is 1/6. Okay? All right. We're going to do it again. This time, let me walk you through the reasoning. Okay. First, we write this as log base 16, 4 to the 1/3. That you've been doing all along. Now, this is log base 16. I take the 4, and I need to write it in terms of 16. So if I had a 16, what should I do to the 16 to get a 4? Take a square root, which is to the power of 1/2. And then that to the power of 1/3, so you get 1/6 again. It's weird because it's the first time somebody's asking you to go the other way, okay?